Instrumentation is a set of techniques and tools used to analyze the physical, chemical, sensory, and microbiological properties of food products. Have you ever wondered how food instrumentation is used to determine the authenticity and origin of food products? Food instrumentation techniques can be used to identify different substances and components in food, detect any fraudulent practice or adulteration, detect containing and additive, determine the quality and safety of products, and ensure compliance with food standard and regulation. There were many types of techniques used to determine the authenticity and origin of food products, but we will explain about three most common techniques used. These techniques include nuclear magnetic resonance (NMR), spectroscopy, gas chromatography (GC), and also isotope ratio mass spectrometry (IRMS). In this video project, we will go through these three techniques in further detail and introduce some communities.
Olive oil is a product that is in high demand on the market. It is due to the fact that olive oil is high in nutritional value and antioxidant qualities such as polyphenols, which protect blood lipids from oxidative stress. Have you ever wondered how to establish the authenticity and origin of olive oil? As I have learned, nuclear magnetic resonance (NMR), one of the food instrumentation that can be used to determine the authenticity and origin of the food product by examining its chemical composition. NMR spectroscopy can reveal important details about the molecular structure and content of substance, such as olive oil. Let me introduce Puan Mazini, the founder of olive oil product, who will tell more about NMR. Hello there, Puan. Can you tell me how you determine the validity and origin of olive oil?
NMR was used in the industry to detect any adulterant or fraudulent practices in olive oil to evaluate its authenticity. As we can see, some olive oil is contaminated with inferior oils or diluted with inferior oils. Specific chemical indicators that indicate the presence of adulterant or deviations from the expected composition of pure olive oil can be found by analyzing the oil's NMR spectra. NMR can also assist in determining the origin of olive oil. Olive oils from various areas and types have diverse chemical signatures. NMR can be used to characterize these profiles, and statistical model can be created to associate certain chemical markers with the geographic origins of the olive. The origin of an olive oil sample can be estimated by comparing its NMR spectra to a database of known profiles.
May I know how the NMR was conducted?
Typically, NMR-based olive oil analysis begin with obtaining a representative sample, extracting the oil from the sample, and preparing it for NMR analysis. After obtaining the NMR spectrum, several data processing techniques such as multivariate analysis and chemometric modeling can be used to analyze the result and draw inference regarding the oil's legitimacy and origin.
Thank you for the clear explanation. I hope we can have more conversation about the instrumentation in the future.
Do you know that the dietary compounds present in the raw material vary according to its origin, and it can affect the quality? For example, milk. Do you know how many types of milk are being selling in the market? As far as I know, there are cow milk. Correct. In some other countries, they also produce horse milk and sheep milk for human consumption. Therefore, an analysis of authenticity and the origin of milk can be carried out using gas chromatography, also called as GC. Chromatography is an analytic technique used to separate volatile compounds and identify almost all types of molecules in the food sample. The authenticity analysis of milk using GC is based on the determination of triacylglycerol (TAG). To perform a complete and successful analysis, GC is usually combined with FID, flame ionization detector. Can you explain more about it? How is the process carried out? Sure. A research group in the Netherlands using GC to differentiate the milk fats from several species. The research group collect the milk from cow, goat, sheep, horse, water buffalo, donkey, and camel. The milk fat are first extracted and the THG and the receipt is carried out by using GC. The GC is start with injecting the milk fat into the mobile phase, and the mobile phase is an inert gas which carry the sample through the stationary phase into the column for separation. The data is then collected in the detector and output in the data system in the form of chromatogram. The compounds present in the milk fats can be observed from the chromatogram and the data table, and this is a way how to differentiate the origin of milk.
Alright, thank you for letting me know the use of gas chromatography.
You're welcome, it's my pleasure.
Hello, Ms. Hidayu. I'm conducting a short interview for my project, and I was wondering if you have a couple of minutes to spare to talk about isotope ratio mass spectroscopy (IRMS) and its application in determining the origin and authenticity of coffee.
Sure, I would be happy to help. What would you like to know?
Great, thank you. So, have you heard about isotope ratio mass spectroscopy before, and how does it is relate to coffee?
No, I haven't. Could you explain what it is?
Of course, isotope ratio mass spectroscopy or IRMS is a scientific technique used to analyze the isotopic composition of a sample. It helps to determine the ratios of different isotopes of element present in the substance. For example, coffee beans have a distinct isotopic signature based on their geographical origin. By analyzing the isotopic ratios of certain elements in coffee, such as carbon, nitrogen, and oxygen, scientists can trace the coffee back to its specific origin.
That's fascinating. So, is it used to verify the authenticity of coffee as well?
Exactly. IRMS can be used to verify the authenticity of coffee by comparing the isotopic composition of a given sample with a reference database of known coffee origin. If the isotopic ratios didn't match the expected values for a specific origin, it may suggest that the coffee has been adulterated or mislabeled.
That's really useful for ensuring the quality and authenticity of coffee. But what are the steps needed to determine the authenticity and origin of coffee by using the IRMS?
To determine the authenticity and origin of coffee, the first step is to acquire the necessary coffee samples from different regions or sources. Coffee beans are then dried, ground, and homogenized to ensure consistency. Next, the analysis will continue with the stable isotope analysis using IRMS. The stable carbon and nitrogen isotope ratios in the coffee are compared to reference samples from known region or sources to allow for the determination of the origin and authenticity of coffee. The isotopic ratios obtained from IRMS are used to create a unique fingerprint for each coffee sample. This fingerprint can be compared to those from known sources to determine the origin and authenticity of coffee.
In conclusion, food instrumentation plays a vital role in determining the authenticity and origin of the product. By employing various techniques such as NMR, GC, and IRMS, scientists and other regulatory bodies can gather valuable information about the composition, structure, and characteristics of the product. By comparing the obtained data with reference databases or established standards, it becomes possible to authenticate food products and ensure their quality and safety. The use of food instrumentation not only helps in safeguarding consumers' health, but also protects against fraudulent practices in the food industry. Overall, food instrumentation is a valuable tool in ensuring the authenticity and origin of the food products, contributing to the integrity of the food industry and the well-being of the consumers.